Hey everyone, so this is my video on a new project that I did with a little navigating robot. And the point of this project was to learn how to do controls on navigating platforms and computer vision and apply that. So this little guy is called the Fortronix Initio, and it uses a Raspberry Pi, and it comes with a little hat which handles the voltage regulation and all the input-output pins, H bridges, that sort of thing. So in terms of sensors, it has a sort of rudimentary distance sensor here. These don't actually return distance, they just tell you that something is within a certain range. An ultrasonic, which does give you distance in centimeters. And it comes with encoders on the wheels. So as far as motors, you have two motors, so these wheels are attached. And there's two servos for the pan tilt on the camera. So about how you control this thing on the Raspberry Pi, you basically use the GPIO. And so I had to rebuild most of the libraries for this thing to fit my purposes. So I ended up building my own kind of class architecture for this.
So I did this entire project in an object-oriented way. I had the wheel classes used encoder classes, so you could, for example, set the wheel to 50 centimeters per second, and every time the update function is called, it'll check if it needs to change the amount of power going to the wheel by adding more, removing, using a PID loop. And I'll talk about this more. The behavior class, it decides how the robot is going to act at any given moment. In this case, it was following lines. The Pi video stream hooked into the pan tilt camera, so I could move the camera around according to what the video is telling it to do. And then I just had another object called the Rover handler, which owned, left wheel, right wheel, a pan tilt camera, and a follow line behavior, and then ran a hardware loop to update them constantly. So the first thing I worked on was how to find the red tape on the ground. And so I initially did this using RGB values and filtering out. But then I realized I needed to switch my color space to HSV, hue saturation value, and filter using the hue of red and allow any amount of light value. So it became a lot more useful that way. So once I was filtering by hue, suddenly I could do all kinds of cool stuff, like just find the red tape and ignore all kinds of other noise. Once I applied the hue filter, I then ran it through a thresholding function, so I got only white or black areas on the screen. And so you can see that's actually doing a really good job of getting the tape, just the tape, and removing any noise. But you still see these black sort of areas that are cutting in between that would mess up with any dumb line following algorithms. So I didn't try to find the edges of the lines. So instead what I did is I ran a line finding program that found thousands of lines anywhere it could. And then I ran a program that I made myself to concatenate all these lines based on their angle, their position, so I could find the main line. And that's what you're seeing here is that gray line is the main line. The nice thing about this is it can find many lines inside of the video, 2, 3 at a time, and identify junctions in the lines so the robot can decide, hey, I'm going to move left here, I'm going to move right here, I'm going to record that there is in fact a junction here. So I initially ran into a lot of issues. The first was just, once I was able to find lines correctly and threshold them, it still would sometimes not see them in different lighting situations. And then I had these weird issues with the PID where I just had a very, very slow response. The robot didn't want to respond correctly. You can see here it didn't even see the line. It just completely lost track. And so then sometimes it would just back up completely. So it just took a lot of fine-tuning, and then finally I was able to start tracking the line correctly. And you can see here the robot's being a bit finicky. It's very, very fast, it stops quickly, and I didn't like that, but this was the first success that I've had in a long time. And so eventually I realized all the issues I've been having were due to bad PID values. I thought it was because of the encoders being bad. The encoders on this robot offer very little resolution, and so I thought I just couldn't get velocity updates fast enough. But turns out it's not that. I just need to have a faster response on my PID. And once I got that, I was able to have this smooth responding robot. And you'll see it overshoots a little bit, but that's actually kind of an intended feature in the sense that I wanted a very smoothly updating robot. It never actually loses track of the lines, you can see here. it'll do a pretty good job on this. So one thing I never got around to doing in this project was to implement a use for the junction finding. Oh yeah, right there, it lost track of the line. Junction finding was the idea that you could map out and all the lines around the house. I just didn't find a use for that. Now that I have a working platform with working code for controlling it, I want to apply this